Hello everybody, Eric here, and welcome to my computational science video tutorial. Today, what I want to do is I want to take a look at the solutions to my students' homework. So this is going to be basically a video solution to the homework. Instead of putting a printed solution online, I'm going to make a video of me solving the homework. So the first homework problem is we want to explain the bit shift operator. Okay, now what the bit shift operator is, in Python, it's this kind of less than symbol. And to understand the bit shift operator, we have to have a basic understanding of binary numbers. So if we want to represent the binary number 3, we're going to write that as 1, 1. If we want to write the binary number 5, we're going to write that as 1, 0, 1. All right, so if we look at some values from this, I'm going to quickly run this program. Now I've run it before, so I'm just going to load it up and we'll get everything running. When we look at our results, we can see here the result for this binary number of 5 is just going to be 1, 0, 1. Now this bit shift operator is going to shift the bits by a certain amount. So 5, then we're going to say bit shift. My editor likes to have spaces around the bit shift operators, but we're going to have 5 bit shift 1. All right, so we're going to shift the bits by 1, and we can see that this double less than kind of looks like arrows pointing to the left. So if we're going to shift these bits to the left, if we have 1, 0, 1, and we shift those to the left, it's kind of like a 0 is going to pop in at that far right space. If we shift to the left twice, we're going to create 2 zeros. And if we shift to the left 8 times, we're going to create 8 zeros in binary. And likewise, we can print out the non-binary forms of each of these numbers. And I'm going to write these without the white space to keep my Python editor happy. So what we can see is when we do 1, 0, 1, we get the result of 5. 1, 0, 1, 0 gives us 10. Now if we have 1, 0, 1, 0, 0, we have 20. And we put a bunch more zeros here and we get 1280. So what's happening here with the bit shift operator is when we bit shift to the left, we're multiplying by a power of 2. So if we do 1 bit shift, we're multiplying by 2 to the first power. If we do 2 bit shifts, we're multiplying by 2 to the second power. And if we do 8 bit shifts, we're multiplying by 2 to the 8th power. That's how the bit shift operator works. It's multiplying by a power of 2 when we bit shift to the left. When we bit shift to the right, instead of multiplying, we're going to see that what we get is division. So we get division when we bit shift to the right. So if we look at the results from the second set of numbers we've put in, well, I've started with this number x, and I chose a very big number, and it's what? 1,234,543. Right, so if we start with this number and we write it in binary, we get this really big number. And when we bit shift it to the right, you can see what happens is this final 1 kind of falls off of the number. Well, what's happening is it's getting shifted off of the end and we're just truncating it. We're cutting it off. If we bit shift by 2, we're going to cut off the last 2 ones. So bit shifting to the right, we're dividing by 2, or 2 to a power, and we're just rounding. We're doing integer division. All right, so that's what the right bit shift is it's a form of division by 2. Every time we bit shift, we divide by 2, or 2 to a power, I should say. So 1 shift is dividing by 2, 2 shifts is dividing by 2 twice, or 2 to the second power, and 8 shifts we're dividing by 2 8 times, or we're dividing by 2 to the 8th power. All right, so that's kind of in words what I was looking for on the homework. Really, I know my students are not native speakers of English, so if people said bit shift to the left is multiplying by a power of 2 and bit shift to the right is dividing by a power of 2, that's great. Some people wrote it out mathematically. For people at home watching this video, hopefully you kind of have some understanding of the binary representation and how we work with them. The reality is I don't really do too much with bit shifts in my daily work, but it's very important, I think, to understand some of the concepts. All right, for the second problem, what we want to do is we want to create a function to compute the distance between two vectors in 3Ds. So I'm going to start by defining a distance 3D function, and I'm going to give it a vectors, maybe u and v, and those are going to be vectors. And what I'm going to simply do is I'm going to figure out a way to do the sums. And there are two ways I can think of how to do this. The first way I can say, well, maybe if we sum up in the x's, that'll be, let's see, it's going to be the first u, which is going to be u0, minus the first v, and then this is going to be squared, right? We're going to, all right, and then we're going to do the y's, which are going to be u1 minus v1, and then we're going to square that, and then we're going to sum up the z direction. So the z's, you can think of the z's as all the z's being added, or the z squared. We're going to do the third element, which is u2 minus v2 squared. Remember, the third element is written as 2, and the second element is written as 1, and the 0 element is written as 0 because we start at 0. So we're summing the squares. Now we take the root of these. So we're going to say that the root is equal to, how about xs plus ys plus zs to the 0.5. So we'll just raise this to the 1/2 power. We'll take the square root there. We want to return the value, so just return root. Now when I look at this, I think I could maybe make the code a little bit simpler. Because I'm going through 0, 1, and 2, I could do this as a loop. So I could say something like the sum is equal to 0, and for I in range 3, sum plus equals, and then I'm going to just copy this little bit of code, and I'll put the letter I where the 0 was. So this might be a little bit beyond what we've talked about in class. We haven't really talked about these loops in my videos, but it's another way to do it. So we can follow the loop here with the sums, which I'll comment out because it's more work than or it's using some logic we haven't explicitly spoken about. And this sum is basically the same as the sum that we have represented here. So this is how we would write a distance function. For the homework, we wanted people to kind of practice it and say something like print distance 3D. Then we'll have a vector here of maybe 1, 2, 3. And we'll have a second. Oh wait, yeah, there should be 2. So many parentheses. Then we'll have a second vector of 4, 1, maybe -5. And this is just going to print this out to the screen. So if we run our program, it's going to compute the distance between these two vectors. I'm going to assume it's right. I haven't tried it. Okay? So that's how our sum works. Or that's how our distance function works. So this would be problem 2 for the homework. I maybe would want to see a few more examples, and more comments would of course be nice. Now the third question had us do some work with turtle. And to use turtle, we want to import turtle. And we want to create 3 basic shapes. Now whenever we work with turtle, I'm going to create a turtle object. And that's in the turtle, and it's going to be turtle. And to create an object, it always is a function. We're going to create a screen object inside a turtle. That comes from inside a turtle, I should say. And remember, with our screen, we always want to end with a main loop. All right. Now, we just want to create 3 objects, and this is incredibly easy. The first one's just going to be a circle. I think a circle is pretty easy to draw. For the next one, we can actually create another circle, but using the circle, we have an input function we can choose called steps. And if I choose 6 steps, it's basically going to create a 6-sided circle. And I could also create a 3-sided circle. Now, some people like to get fancy with this stuff. And what we can do is we can change the color of our turtle. And I can make it blue. And here I can say, I can make it, how about green? So we can have some different colors we're throwing into our turtle. Now when we run our program, we should see. All right, so I tried to run the program. I realized there was a mistake. The mistake was I spelled screen with only 1 E. We need two E's in screen. We need to spell correctly. I was typing too fast and I made a mistake. Now I want to make this window small. So when I run my program, I want to see my turtle pop up on screen. So here we go. We're drawing a circle. Now we're drawing a hexagon. And now we're drawing a triangle. So that's the easy way to quickly create 3 shapes using Turtle. So this has sort of been a virtual kind of answer guide. I do want to show quickly, some of my students were very creative when I was grading the homework. I really like this one. They made a Pac-Man image. They used a part of a circle and a bunch of lines and some basic skills, and they drew, I believe that's Blinky, and Pac-Man chasing after his pellets. All right, well, that's everything for this tutorial. Thank you for watching, and keep on coding.